Hey guys, and welcome to Scientific Drinking. Tonight we are drinking from the Old Shamrock Pub. Welcome, Scientific Drinking and Glee Club. This is owned by former guest drinker, Gary O'Neill. You might remember him from the Thermal episode. Cheers, buddy. Tonight we're going to be talking about systems engineering.
And stuff.
Systems engineering and stuff. Cheers. Stick around.
Cheers.
That's the audience. You see him? You see him in there?
I don't see any.
They're in there.
That's
yeah, all of the internet is actually in there.
Hello, Internet.
Yeah,
Welcome to Scientific Drinking.
This is a low budget operation, Ron. I'm on intern pay.
You don't get that much more pay when you work for NASA.
You'd be surprised what the difference is between a GS7 and a GS11.
Is it like Lambo difference, or is it like, oh, I can finally buy a Subaru difference?
I can finally buy a Subaru difference.
Well, you're working for NASA, so you're obligated to buy a Subaru.
Is that the way it works? I didn't know that.
I mean, yeah, most of their demographic tends towards the technical end of things.
So that's why we see Subarus and Teslas in the parking lot.
That's true. I think Tesla has cornered the market on NASA engineering.
That
if you work for NASA and you have two dimes to rub together, you gotta buy a Tesla.
Yeah. I mean, if you've seen SpaceX's facility over there, it's nothing but Teslas in a couple trucks, right? And as soon as the Cybertruck comes out.
Can you imagine all the Cybertrucks in a parking lot?
I really cannot imagine.
I'll have to put one of those on a Falcon Heavy and throw that shit somewhere.
No, have you seen the background of the Mars? JPL released a series of posters. It was like Gateway Moon Mars. And the Mars one has a Cybertruck in the background before the Cybertruck was ever a thing.
I knew a house that had two Aztecs parked in the driveway.
I don't know how two people can make such bad decisions. If you think about it, the only person that's allowed to make a decision so bad as to buy a Pontiac Aztec was the guy from Breaking Bad, Walter White.
You are watching Breaking Bad, and you would know that.
Yeah.
So my job on the Space Shuttle was basically to be the engineer for the auxiliary power units subsystem. Really basically consisted of these three APUs in the back of the orbiter, but the job of the APU was to be a turbine spinning at about 80,000 RPM, and that turbine at about 135 horsepower could power one hydraulic system in the orbiter. And the orbiter had three hydraulic systems for two fault tolerance.
Okay.
So a very robust system. So my job was just to basically test the system when it came back from orbit to make sure it was ready for the next flight. Space Shuttle got to the pad. It's our job to refuel the hydrazine and the auxiliary power unit fuel tanks. The system activated at about T-minus 5 minutes and counting. We powered the system up 6 minutes, 15 seconds prior to launch. At 5 minutes prior to launch, the pilot would start the APUs, and then they would operate all the way up to orbit. Once the Space Shuttle got onto orbit, they'd run for a little while the crew did their on-orbit checklist. One item in that checklist would be eventually just to shut them off, and they'd stay off for the whole mission until they're ready to come back. So the APU system only worked when you needed hydraulics. And you really only needed hydraulics for launch, return, and landing. They would turn them on when they were doing their entry checklist, and basically you would power them up, make sure they're healthy, make sure they're working. Getting the APUs up and running was an important part of the reentry process.
Hydrazine's nasty stuff.
Yeah, it's gross.
Tell us about where we're at.
Basically, it's better if I don't talk about it. I don't know. It's really bad stuff. So the funny thing about hydrazine is you would never know you're looking at it. It's a little more oily than water, but it looks just like water.
So it's like KY jelly.
No, not at all. I mean, it looks like water. If you had a glass of water and a glass of hydrazine in front of you, the only way you could really tell you were looking at hydrazine would be maybe the hydrazine, if you swirl it around a little bit, would be a little oilier. And obviously, if you could smell it, it would give you cancer and you would die.
How did it taste?
I mean, I don't know. If anybody watching this knows what hydrazine tastes like, man, I would love to hear that. There's probably some scientists out there and researchers who would also like to know.
That reminds me, oxygen, I just saw oxygen sloshing around the tank in a SpaceX video recently, and it was like blue. And I didn't really expect it to be blue. For some reason, oxygen, it's in the air, it's transparent, right? I thought it would be like this whitish crystalline stuff, I guess, but it was blue. Yeah.
I don't know. We didn't fly cameras that could look at hydrazine and the fuel tank. The Space Shuttle fuel tanks were kind of neat. They were just spheres, but they had internal diaphragms that separated the pressure. It was a blowdown system, so you pressurized it prior to launch, and that's all the pressure you got.
Right.
So there was a diaphragm that separated the hydrazine fuel from the pressurant gas. Drop dead simple, never failed. I mean, the fuel tanks never failed. We had two APUs blow up right after landing on STS-9. You can Google that. It's a very interesting story. There was an injector tube failure. The fuel injector tube inside the APU on one of them developed a crack. When the APUs were being assembled, there was some residual stress in this long injector tube. And that injector tube developed some stress and cracks during flight. Cool thing was, well, I mean, it wasn't cool at the time, but that after Columbia landed, one of the APUs developed a fire and failed. And then shortly after that one failed, the other one developed the same failure, did the same thing, like fuel escaped where it wasn't supposed to escape to, caught fire in places where it wasn't supposed to catch fire. The vendor had to go back and redesign that injector tube and work on their manufacturing processes. But that was a dramatic thing. I mean, if that had happened 10 minutes earlier, that would have been a catastrophic thing.
Right. Now, your title working on these APUs was an integration engineer, right?
We call ourselves systems engineers. Being a systems engineer in the language or the parlance of like shuttle ground ops was meant that you were responsible for a system on the space shuttle. You could be a booster mechanical systems engineer. You could be an electrical systems engineer. You could be a hydraulics or an auxiliary power units systems engineer. It didn't mean you were a systems engineer. It meant you were an engineer for that system. These days, if you say you're a systems engineer, people are going to tend to assume that you do systems engineering.
Right.
I was not a 4.0 student in engineering. I studied aerospace, but when I went to work for the space shuttle, I really quickly realized it was more of a operations, a little bit of leadership. You had to lead the technical organizations, like the technicians and stuff you talk to.
You know, out of curiosity, anyone here is a 4.0 student? 4.0 student? Anyone? No, it's not a continuity error. It's all on film. One of the things that I grew up on, well, I don't want to say grew up on, but that drove my education was the MIT Open Courseware, a program for systems engineering. But it was all about the space shuttle, and they made the argument throughout that Open Courseware that it was the space shuttle that drove the existence of the field of system engineering. Now, since then, I've had a few textbooks and things that claim system engineering came before that. So I would argue that's correct. So, did the space shuttle drive the legitimacy of the field of systems engineering then?
I think the space shuttle was an example of how you might approach architecting and...
What's architecting? Talk to us about architecting. I mean, architecting isn't building a building, right?
So the architecture would be, how are you going to divvy out the functions that this thing needs to do in a logical way so that you can hand off parts of it to like a team or a different company or a whole other organization. Let them do their part of it, and then later on things are going to come back together, and when you put the pieces together, you're going to have a functioning system. The architecture is it's the art of breaking it into manageable pieces.
Wait. You said a science is an art.
Oh yeah, well, systems engineering, it's an art and it's a science.
So we talked about your experience with the space shuttle as an integration engineer / system engineer, but not systems engineer, because that's a different thing. But now
we work together.
You work together. You are a fleet engineer, though. I mean, you need to have a uniform.
Oh no. We cannot allow ourselves to think that.
What's your job with the logistics module? And actually, more importantly, what led you from working on APUs to doing what you're doing now? Because it seems pretty different to me.
I just like the idea of being a systems engineer. It's the idea that you start with a blank slate and you get to figure out what something should be. Systems engineering is at the very front of the inception of an idea.
But you weren't doing that.
No, I wasn't. In my previous job as a space shuttle engineer, my customers' needs were, we would like you to fly the space shuttle without killing people. In my previous job, my one task was to process the space shuttle for launch. Not a lot of creativity required. Integration engineering was a job that I had for a couple years, where it was basically integrating the satellite onto a rocket.
So this was after the space shuttle.
Yeah, this is after.
The space shuttle was retired, and this was 2011?
It was. I transitioned into another opportunity, another office at Kennedy Space Center, the Launch Services Program.
Okay.
So the Launch Services Program has a contract to go buy commercially designed, commercially built rockets. Only 20 minutes? I feel like I've been here all night.
Oh, okay.
It gave me a little more free time to explore the opportunities within NASA. Being an operations engineer is great, except when the thing you're operating gets retired. I started looking for other opportunities well in advance of the actual retirement of the space shuttle. I ended up with the Launch Services Program for spending about 5 years doing NASA spacecraft to commercial launch vehicle integration.
Yeah, that's pretty lucky, right? Because there's only... Was it before the space shuttle, there was 15,000 people on the Space Center, and it will drop down to only 7,000, 7,500, something like that?
It was a big hit in the workforce.
But it was a big change. And now we're back up to 17,500, 18,000 now.
It's a great time to be in the aerospace business. There's a lot of opportunities at the Kennedy Space Center. We're flying tons of commercial rockets. Yep. Blue Origin's building a huge facility out here. They're going to be flying rockets and processing spacecraft here at some point. We've got SpaceX out here. So yeah, in addition to all those commercial companies operating here, there's a bunch of NASA programs operating here as well. Obviously, we have SLS. We've also got the Orion spacecraft, which is a pretty amazing thing. The fact that we are assembling a NASA spacecraft here at the Kennedy Space Center is really unusual for Kennedy. It's the first time that's ever happened. I mean, the space shuttles were built in California. The Apollo spacecraft were built elsewhere. But the idea that the Orion spacecraft is actually being assembled here at Kennedy Space Center, it's really cool. It's really amazing.
Well, something else new is happening, and that's the logistics module. which we're working on.
Ah, Gateway.
Yeah, Gateway, right. So
Yes.
let's transition to that. So
The beer logistics service to the moon.
we can do that. I mean, there's no reason that we can't integrate a keg onto there. Gateway Logistics Element Architecture. So,
Right, my favorite word, architecture.
which I'm not officially part of. I did sticky tape my name on there. So we were talking about how you're now a fleet engineer.
Right.
And it's a pretty rapid transition, or well, radical transition.
No, I wouldn't call it too radical, but it's a nice change of pace for me. It's exactly what I wanted to be able to be doing at Kennedy Space Center. And every day, I cannot believe my luck. This is the job I would have designed for myself if I'd been able to design a job.
You and me both, sure.
Oh, hey. So I've said it several times. It sounds silly to say it all the time, but I'm a requirements nerd. I don't know what it is about criticizing requirements or finding flaws in the way
You
people
just
write
love
their
being
requirements.
better and more right than everyone else.
But this is the only thing I'm good at. I just have the right combination of analytical mind and anal retentiveness.
You never thought I'd hear someone brag about being attentive, right?
It's the lamest humble brag I'll ever make. Yeah, and it's not a great thing to brag about being able to be the bureaucrat who tells people what they have to do.
No, you're not the nerd we deserve. You're the nerd we need.
The Dark Knight.
So yeah, in Gateway Logistics, our job is currently to figure out the right set of requirements for the logistics service to the near rectilinear halo orbit where the gateway will be placed. Our office is tasked with delivering supplies to that location. Our office is taking the approach. We want to provide a commercial service, much like the ISS commercial resupply services. A little bit like the commercial crew program where NASA doesn't own the service. They don't own the hardware. They don't own the spacecraft. They are purchasing the service from a commercial provider. The idea being that NASA should be continuously doing what we're best at, which is buying down risk, figuring out how to do new and interesting things. To keep redoing the same thing we've always done doesn't make sense when the commercial market might provide that capability also.
A lot of people paint this entire going to the moon thing as NASA versus the competition. Really, I mean, at least for me being here so far, it doesn't really feel like a competition. It feels like trying to bring the commercial industry with it.
Yeah, I think the right terminology has always been partnership. A partnership between NASA and a contractor. Sure, we are writing requirements, we're establishing contracts, we're giving them money to do a thing.
Right.
But the essence of what we're trying to accomplish is with us as the funding source and you as the implementer, or the guy actually doing the majority of the work, we form a partnership together to go accomplish a common goal. I mean, everybody needs to make money. Every ongoing concern, every company has to have a bottom line that they meet. We want to put that money out there in the industry so that there's an industry out there that does things that are valuable. If there wasn't a government entity like NASA trying to promote new frontiers, then what would be their motivation, and would they really see the value, the payoff versus the risk?
What reason is that? I mean, the amount of capital investment and the amount of uncertainty is huge. There's no incentive to do it. So the NASA's job is to just throw a bunch of money at the problem and say, hey, listen, we want to go here and this is how we want to do it. And then once it's been established, once there's some framework or some infrastructure, like the International Space Station, like low Earth orbit, and now that it's there, then all these commercial partners can go there. It's the same thing with the moon.
Sure. There wasn't a lot of commercial interest in designing and building a space station. Now that the government has funded it, flown it, built it, and established it, it has now become a destination. When we flew Dennis Tito to it, the ISS is now the scientific installation to go to do that, or in some cases, a tourist destination.
And SpaceX just announced that they're going to start selling seats in their Dragon capsule, which is going to be fully autonomous, not require a pilot, for each, starting around $50 million, which is kind of a steal.
So with the government as the anchor tenant, we come in, we provide the seed funding, so that, yeah, we benefit, but would that have happened if the government hadn't stepped up? That's a little bit of what we're doing with the logistics module. The idea is, okay, we have commercial flights going to the space station on a regular basis. It's almost become routine. I mean, how often are we sitting at our desks and realize, oh, we're flying a rocket today?
Oh shit, is that time already?
Rocket 30. We are reaping the benefits of the previous government investment in the idea of a commercial resupply service.
We got an emergency refill.
So we don't own the spaceship, we don't own the rocket. There are a ton of requirements.
Just for the record, that's exactly how you pull a Stella.
That's a great quote.
There you go. There you go.
Anyway, I'm monologuing.
You sly dog! You got me monologuing!
So the space station program had this idea of getting resupply of the ISS without the space shuttle. I mean, the space shuttle was a very expensive resupply service.
$400 million for a space shuttle resupply service.
And risky. I mean, we flew 6-7 people every resupply flight. So all of this has led to NASA being willing to say, you know what, we're going to have this little mini space station, spacecraft.
Right.
Go figure out how to make happen on the moon and around the moon what has already been done for the space station in low Earth orbit.
What's so difficult about having commercial resupply service around the moon compared to having it in Earth? Right?
Well, you know, I don't think of the challenge as being the location so much as the concept of operations that we're working with, which is when you fly a commercial resupply ship to the ISS, if you have issues with the module, there are people there. Up until recently, the concept has been bring your module to within reach distance of the arm, and then we will berth you to the space station. The arm grabs you, you're floating, the arm grabs you, berths you. Our concept for Gateway is that we need a logistics flight to arrive, autonomously dock on its own to the Gateway with no people involved whatsoever.
Yeah.
Hang out there for a month or so. When the crew mission is over, we will autonomously undock and then go dispose of ourselves. I think all that autonomy happening in lunar orbit is the challenge for logistics.
So if any of my 100 viewers out there happen to play Kerbal Space Program or know someone who has actually made like an NRHO orbiting spacecraft or something, that would be news to me. That'd be great because it requires
That'd be really cool.
Yeah, it requires a lot of control and station keep, which isn't really an intuitive thing for Kerbal Space Program. So let me know.
Oh yeah, just go watch Interstellar and see how easy it is to dock.
Yeah, it's super dock. It's super easy to dock. 40 minutes.
3 hours.
No, not 3 hours. You mean, come on, bullshit. You've been enjoying this. Yeah, even me. You talk about yourself for a while.
Yeah.
Requirements.
I'll enjoy it right up until I see myself on camera.
All right, guys. So yes, but the Kohi.
Kohi.
All right, guys. Thanks for watching. See you next time at Scientific Drinking. Cheers.
Cheers, bro. Too wild and crazy.
Wild and crazy. So how did
breaking things?
So
cut.
Jesus, yeah. Seriously, edit point right
So-
there. I have no idea what. Yeah.
I thought that was a dog, and I thought it died.